All right. Good morning, everyone. My name is Edl Schamiloglu, and I'm a distinguished professor at the University of New Mexico. I wear several hats here, but the hat that I'm wearing for this panel session is I'm the special assistant to the provost for National Lab Relations, and this position was started in 2017 after the last MOU for the Sandia Academic Alliance. With me are several panelists whom I will introduce after I give my brief introductory remarks. Okay, this is a Sandia slide on behalf of Sandia. And so for more than 70 years, Sandia National Laboratories has delivered essential science and technology to address the nation's most challenging security issues. And you can read the purpose, the vision, and the mission. And all I can say is that the work that Sandia is doing is ever more important in these days where there's such turmoil all over the world. So a couple of updates. Things have been changing at Sandia Labs. So about 5 years ago, or by now 7 years ago, Sandia did a survey of its workforce and identified from which universities they draw the majority of their workforce. And after that exercise, they identified these 5 institutions as the original academic alliance partners. So we have Georgia Tech, Purdue, Illinois, UNM, and UT Austin. UNM is by far the largest workforce provider to Sandia Labs, which is not surprising. And these other universities have niche areas where they are particularly prolific in providing workforce. As an example, Georgia Tech in particular is known for the signal processing graduates. Purdue is known for the mechanical engineers, and so on and so forth. Just this year, Sandia added 2 more academic alliance partners. They added Texas A&M and they added UC Berkeley. And just as the University of New Mexico has 2 satellite efforts associated with it, namely New Mexico Tech and NMSU, Berkeley also has 2 satellite efforts affiliated with their partnership, and that's Stanford and UC Davis. So the Academic Alliance is now comprising 7 universities. And Sandia has eliminated the term Sandia Academic Alliance. It's now called the Sandia University Partnership Network. And within the Sandia University Partnership Network, there are different levels of engagements. On the left here, you see alliance partners, and this is what used to be called the Sandia Academic Alliance, but the alliance partners are the 7 institutions that are formerly known as the Sandia Academic Alliance universities. So the verbiage is that these are, the 7 universities I showed on the previous slide are the alliance partners as part of the Sandia University Partnership Network. I'm not going to read this slide, but I'll leave it up for a minute so that you can read it. So as you go to the right here, the level of engagement decreases. And as part of the alliance partners within the Sandia University Partnership Networks, there are set-aside funds through laboratory-directed research and development programs and other efforts that are exclusive to the alliance partners. So there is a benefit for being an alliance partner within the Sandia University Partnership Network. Okay, I know we have non-UNM folks in the audience as well, but the next couple of slides is particular to UNM and UNM faculty. So if you are a UNM faculty and if you're interested in engaging with the Sandia University Partnership Network, how do you do that? And the answer is it's quite easy. You go to this URL, and if you don't screenshot this or remember it, you can always go to the School of Engineering website and go under research, and then you'll find this link. So what this link does is it takes you to this page, which is the School of Engineering Sandia University Partnership Network website. It is not restricted to engineering faculty. It is available to all faculty. The Office of the Vice President for Research is working on revamping their website, and once they revamp it, they will have a similar page on the OVPR website. But for now, since engineering got this up and running, it's available to all faculty. So when you come to this page, you can click on the left here, which says Sandia University Partnership Network. And then here, you can click on this tab that says UNM Faculty Connect Your Research with a Sandian. When you click on that, you're going to be prompted for your net ID and password. And then once you enter that, this is where you land and your name will show here. And then on the left here, if you click on Alliance Partner Research Form, it takes you to this page where you can insert your name, your position, your department or center, your email, your phone. It asks you if you are a US citizen or not, but citizenship does not prohibit collaboration with Sandia, but it may make it difficult. And as you scroll down on the form, you can pick a focus area. These focus areas are areas identified by Sandia Labs as their core research areas where they are seeking engagement in. So you can select one of these areas, or if you find that your expertise does not align with these areas, you can click other. And then regardless, you can then briefly 10,000 characters, describe your research interests, and what you are seeking to engage. And then you can upload 3 files. These could be publications, these could be your CV, but you upload those, and then you click on Submit Form. After you click Submit Form, a copy comes to me, a copy comes to Stephanie Gallegos at Sandia, and Sandia has a mechanism whereby they filter these and they distribute it to the proper research areas, initially at a high level through the foundations, but then at a lower level. And after a couple of weeks, you who submitted the form gets feedback from Sandia saying they're interested, they're not interested, they want to meet, they want to follow up. So this is a good way of making a connection with a Sandian. In addition, we're close to finalizing the Sandia-UNM Faculty Loan Program. And what this program is, it can allow a UNM faculty to be part-time on-site at Sandia, doing research at Sandia National Labs as a visiting member of the technical staff. It also allows a Sandian collaborator to come to UNM and spend some time, typically 0.25 to perhaps 0.5 FTE at UNM. They'll get the title of visiting research professor. The reason we selected visiting research professor is because that title is not in the union collective bargaining agreement. So a Sandian who comes to UNM with the title of visiting research professor can then be a PI on a proposal from UNM to agencies that a Sandian cannot access through Sandia. So as an example, they can come to UNM, be a visiting research faculty, write a proposal to NSF, and if the proposal hits and they draw funding, then Sandia will bill UNM for the Sandian's time spent at UNM, and UNM will charge the NSF grant. So this is a good way to grow a collaboration. It gives Sandians direct access to students. So we think this will be a very positive program. And with that, I'd like to invite the first of our panelists, Chris Perfetti. Chris, are you on the line?
I am.
Great, and I'll drive this for you. So just tell me when to flip the slides.
Sure, thank you, Edl. Yeah, hello everyone. Sorry if I missed the start. I had class, so I had to book it between there and here, but I'm happy to be here now. So my name is Chris Perfetti. I'm an assistant professor in the nuclear engineering department here at UNM. I arrived at UNM in 2018, and prior to that, I was a R&D scientist at Oak Ridge National Laboratory for about better part of 8 years. Prior to that, PhD from the University of Michigan. Prior to that, PhD from Florida. I had a strict I-75 only policy for the first part of my life, and then I made a wrong turn and just kept going on 40 and ended up out here. So we can go to the next slide, please. Thank you. All right. So my work deals with sensitivity analysis and uncertainty propagation. I guess a broader picture of my work is that my goal is to understand how neutrons interact with matter. So some of my research deals with simulating how neutrons interact with matter, and some of it deals with understanding the sources of uncertainty in those simulations. So those simulations on the left, they'll start with a nebulous cloud of input data. I use that cloud graphic intentionally. It's a nebulous cloud because we have uncertainty in the nuclear data, the nuclide densities, the material densities, the dimensions, basically in everything that goes into the problem. And then this uncertain cloud goes into the computer code, purposely modeled as a black box. And then we get some results out of there. We get things such as how close to a self-sustaining reaction is it, critical reaction. We get things like dose rates, reaction rates, fission rates, those kinds of things. And one of the goals of my research is to understand how uncertainty in the inputs propagate through the simulations to introduce uncertainty in the outputs. There's other goals for this too. So some other goals are trying to find ways to make qualitative analyses more quantitative. And another goal is identifying relevant benchmarks. So say that you have a stroke of genius and you come up with an awesome new nuclear reactor design and you want to build it and you want to be able to license it and prove that you know how it will run, right? Prove that you understand the sources of uncertainty in the simulations and that the simulations will be accurate. So the research that I worked on allows us to identify similar benchmarks, to identify the sources of uncertainty that we need to validate, and to identify gaps in the uncertainty that we have. So really quickly, going on to the next slide, please. Here's a little appetizer of the research I've been working on here at UNM. I have 14 graduate students and hiring a 15th an undergrad right now. So lots of stuff going on. And here's just a good sampling of the projects. It's not a Monte Carlo sampling, but it's a non-random sampling. My work usually deals with Monte Carlo methods, so there's lots of random sampling and things like that involved. So the first project, the one in the middle, is oh, yeah, there we go. We are extending the sensitivity analysis to look at other kinds of things. So traditionally, the sensitivity analysis has been limited to criticality types of problems. Is it how close to critical is it? And is it safely far away from going critical? However, some research that I did a couple years ago enabled us to broaden this to different types of responses to get uncertainty in nuclide reaction rates, neutron fluxes, those kinds of things. And the research that we're working on now is extending this to time-dependent responses. So getting uncertainty in how the nuclide composition of nuclear fuel changes and gradually evolves over time. This is important because some of the key parameters for controlling nuclear reactors have, if you have your binoculars, it's right in that center graph right there, but it's the uncertainty in that parameter is about 100%. This is the key parameter for controlling nuclear reactors. It's very highly uncertain, probably because the data is a little bit overestimating the uncertainty, but that's something that we can quantify too. Another aspect, and really the goal of this project with this time-dependent sensitivity analysis, is to understand the sensitivity of observable quantities, such as the final nuclide composition of materials, to all the weird stuff in the middle. Right? We might have nuclides that have very, very short half-lives that are transmuted quickly. We might have things that absorb neutrons instantly and are not around because of that. In either case, we have all this nuclear data between the start and the end of some of these time-dependent simulations that is highly uncertain. Here's a plot in the The blue and the red plot down there plots some of that nuclear data. You don't need to be an expert in nuclear data to see that the red line is very different from the blue line. Blue line has all this structure, all this detail. The red line should have that detail, but it doesn't because the red isotope is too short-lived for us to actually measure its nuclear data. So we're trying to infer what this nuclear data should be by using these sensitivity coefficients, trying to do basically a Bayesian analysis to calibrate this nuclear data. Another project I have in the upper right is we're along the same theme of trying to use these methods to infer properties of things. Instead of nuclear data, we're trying to infer the plasma properties inside of the Z machine. What's the burn time for the plasma? At what temperature is the plasma igniting? Those kinds of things. We have observables from the radiation detectors that look at that detect neutrons coming off of the ignition, and we use that to try and, or we are trying to use that to calibrate this the uncertain plasma properties in that ignition. In the lower right, we have a little bit about this project. So in this project, we are extending this uncertainty analysis, the sensitivity analysis, from the realm of neutrons, where it has traditionally lived, into photons and electrons, because there's a large degree of uncertainty in photon and electron nuclear data. It's very, very uncertain. And we're trying to quantify the impact of that uncertainty, and ideally to try and reduce that uncertainty through these Bayesian types of methods, which allow you to calibrate your data and reduce the uncertainty from 100% or 1,000% or something terrible to something more manageable. Other projects I'm working on include, I have some students working with Los Alamos on high performance computing. So just trying to figure out how we can write better algorithms for modeling neutron transport, or just actually radiation transport in general, trying to figure out how we can accelerate these simulations, make them more accurate, those kinds of things, make them scale well to GPU-based infrastructures, which actually is also a point for this project that I'm working on with Sandia that Aaron will probably talk about a bit more in a second. And other just general projects, looking at calibrating nuclear data, making the Bayesian adjustments even more helpful, even more realistic, and then also poking a little bit into cybersecurity along the theme of trying to make qualitative analyses more quantitative. I have a PhD student, possibly two soon, working in that area. So I think I'll probably end a little bit early here, but that's the gist of my research, trying to understand the sources and the impact of uncertainty in radiation transport simulations. So happy to answer any questions about that and about the collaboration that we have with Sandia, which I feel has been very, very valuable.
Great, thank you, Chris. And this is a nice segue next to our next panelist, Aaron Olson with Sandia Labs.
Hi, thank you, Edl, and thank you, Chris. So I've got a couple slides. I don't think I'll share quite as much technical as Chris did, but maybe talk a tad more about our relationship and how it's worked with some a twinge of technical stuff in there. This first slide had the right. We're getting the slide built out a little bit. Cool. So. Most of this work is based on a laboratory directed research and development project that I'm currently leading. It's in its third and final year. Some of this work has been done under more stable programmatic funds that we have. I say stable in that they don't end at hard stop after the number of years that you proposed with a maximum of 3, like an LDRD. LDRDs are great opportunities to try new things. And to build new collaborations, which is exactly what we've been doing in the case with Chris and myself working together. The main idea for my LDRD is in this top line to develop efficient uncertainty quantification and stochastic media, mixed Monte Carlo sampling transport methods for the GPU. In other words, to develop new methods to figure out if there's uncertainty in the input, how much uncertainty is there in your output, and to look at a very special case of uncertainty that we often refer to as stochastic media. Stochastic media examples, especially for radiation transport, are like figuring out how sunlight's going through clouds, or how lasers are going through Rayleigh-Taylor instabilities, or how neutrons are going through pebble bed fuel reactors. And then to develop a framework that allows us to look at this special source of uncertainty in a broader, rigorous uncertainty quantification framework, and try to figure out how to do all of this efficiently on the graphical processing units that are in many ways the craze for high performance computing these days, to be speedy and fast. Next slide, please, Edl. So there's a lot on this slide. Some of it I won't talk to, but on the left is a summary of the goals of the project, and then some of the papers that we've had, with a highlight on the stuff that we've done with UNM. When I proposed and was on track to be getting this funding for the LDRD, Chris was a fairly new professor at UNM, and of course had come from doing R&D work at another lab. And we had begun to talk with one another about where our research interests and goals aligned. And he's done a lot of work in UQ and sensitivity analysis, which was very synergistic with especially the UQ thrust of the project. So we put together a proposal to have a plus up to the LDRD that was through a special program set up for Sandia and New Mexico universities and for early career professors and scientists. So it was a good fit. That's the primary mechanism by which we've been working together now for almost 3 years. In the upper right-hand side of this slide is a conference paper that we keep submitting to conferences that keep getting canceled due to COVID, but hopefully it'll stick this time, where you can see that Chris is the lead author, essentially testing out if methods that he's developed in the past are likely to apply well to our problems. And then below that is a paper that actually did get presented by a student of his that was also a student of ours through the program, Rowdy Davis, taking a look at improving some of the validation efforts for one of our big codes. And that's all I've got for an intro.
Great. Thank you very much, Aaron. Our next panelist is Professor Tito Busani from the University of New Mexico. Tito.
Yeah, good morning. So I'm here, I'm an assistant professor at the University of New Mexico, Electrical and Computer Engineering, and my lab is down at Center for High Technology Material. So I give a brief overview, pretty much of the research we're doing and the type of collaboration that we have with Sandia National Lab, specifically in LDRD, Academic Alliance, and also in ACORN. My research mainly was for many years in electronics and nano devices. So we develop, as you see on the left, we develop specific nanoprobes that allows fabrication of qubit and actually in-air nanopatterning. We do sub-nanometer lithography with in air, but we do 0.7 lithography, 0.7 nanometers, so less than a nanometer. Lithography for fabrication of FinFET or for fabrication of qubits. This has been a long project, and the ability of this project also created a lot of ability at UNM to design material and design fabrication process for material to enable novel devices. The ability of this project is also, as you see on the top left, is to integrate, and we are not just in fabrication, but we are research is mainly in optoelectronic. The ability of fabricating system that at the same time they have 3 components. One component is an optical emission, so a deep UV laser, which can be used for surface surface modification, especially when you apply this technique in qubit fabrication. We use that for sub 200 nanometer lithography, close contact with the surface. But the ability is also at the same time we fabricate probes that they are able to be nano laser emitter using wide bandgap semiconductor. At the same time, they are electrical conductor. And at the same time, they allowed mechanical contact for fabrication. So this has enabled research also in biology in order to control, we have proposed research in order to control, to analyze a cell in a large scale using multi-probes. So in other words, stimulate the cell in one location and understand and mapping the response of the cell in a different location of the cell. This can be applied to a single cell and multi-cell. Is also used in biology to analyze, for example, the behavior, the health of the leaves for projects related to agricultural. Specifically with Sandia, we have developed fabrication technique on wide bandgap semiconductor, which include aluminum nitrate and gallium nitrate, and different type of nanocavity laser. So the ability with Sandia is to integrate, to work with lithium niobate material, which are a high piezoelectric material, for what I call piezophotonics, but in reality, what we do, we use the component of the optical emission, and at the same time, the component of the high piezoelectricity of the material in order to modulate an electric signal, specifically the interaction between the optical emission, so the photon interact with simply it's called a Brillouin effect. An interaction creating an upward and downward shift in phase can be used for a phase modulation. We work on integration platform of silicon photonics with lithium niobate in a 10 to 100 gigahertz regime. And also this has been used in a frequency mode for optical image compression. Can be extremely used for satellite imaging, for example, to reduce the number of data that has been collected. And of course, we don't work directly on machine learning, but this type of platform is on chip platform, is not, so the image filtering and image recognition is on a chip type platform and not on a software platform. Just want to remind that the collaboration with Sandia as proposed, we had also an acorn, which actually we also using to communicate with the local high school, the value of the academic alliance internship between a UNM and Sandia. So providing a small project for an intern during the summer in our lab, so they can have a direct opportunity to understand what kind of research is ongoing at UNM and the national labs, and which is a good communication for the local community. And also this kind of work, which I'm not showing specifically slides on executing work, because obviously some of this work is under patent review, and some of this work has been recently submitted for publication. But it also will be presented to international conference in San Jose, which is in nanopattern and lithography, and has been also enabled a collaboration with Zyvex Lab and University of Austin. I think this is all. My group, just a brief review of my group, I have 4 PhD students, 1 postdoc working on this different subject. Thank you.
Great. Thank you very much, Tito. And Tito mentioned the word acorn. So typically in the LDRD process, if a UNM faculty wants to team up with a Sandian on an LDRD, they have to do so ahead of the proposal submission. But there's a special program called ACORN, which allows a Sandian who's awarded an LDRD grant to bring on a junior faculty from UNM after the fact if there is mutual interest. And that's what Tito referred to. Great. Our 4th panelist is Kim Butler with Sandia National Labs. And Kim, you've got the floor.
Great. Thank you so much. So my name is Kim Butler. My background is in a kind of complex background in molecular biology and genetics combined with nanomaterials. And I have additional training in understanding medical device development and sort of clinical testing development. So that training was at the FDA. So my background is in how you might take materials and actually take them into the biologic space. So what I do actually at Sandia, so I kind of have, I'm going to go over a number of my projects, and I'll end with the one that's got the current LDRD that is, that I have the academic alliance under. So my lab focuses a lot on the biologic interactions with novel materials. So how do novel materials interact with biology? How can they be utilized for detecting things in biology, seeing things into biology? And so I have a lot of work on nanomaterial development. So can you develop novel nanomaterials for delivering cargoes to hard to deliver species? So for example, plants, can we develop nanomaterials for development in plants? Can you deliver hard to deliver cargoes? So I had a prior collaboration through a previous academic program at Sandia called the Campus Executive Program, which was with UC Berkeley and Jennifer Doudna. So that gave me an opportunity to work with Jennifer Doudna on how we could develop some CRISPR and nanomaterials for delivering of CRISPR. We develop novel imaging agents. So a lot of my work is involved in, can we develop methods to either image and see things using magnetic sensors, novel magnetic sensor development, IR, so working into developing imaging agents in IR window 2 particularly. So that work is involved with a lot of MOFs. I do a lot of work with metal organic frameworks as a method to do biological interactions. So I also have work on doing CRISPR detection and CRISPR development, and for a lot of stuff on disease detection and therapy. So another area of work that we have is in understanding bone sensing. So genetic engineering for bone. So can we understand how bone cells grow, how they make bone, how they sense fractures from a materials perspective? So can we understand how changing the genetics changes the material characteristics of the strength of bone and how it's able to sense and recruit for repair of a fracture? So I'm going to end with the LDRD that I'm currently working on, which is the one I was lucky enough to get an academic alliance with UNM. So we're developing metal organic frameworks for disease detection, in particular looking at detection of viral and viral families with a focus on, can we use metal organic frameworks to create an extremely rapid sensor to detect infections? Ideally, that doesn't require cold chain, that doesn't require all of these very complex machinery that we had to use for doing COVID detection. So metal organic frameworks have some really unique principles. They can quench fluorophores, which means you can use a simpler system for detecting the virus. They can biostabilize. So MOFs are known to stabilize biologics. So you can potentially avoid cold chain. So it actually decreases the requirements for creating this kind of thing. This is a fairly new area. There's not been a lot of publications in it. So we're working to see if we can actually do this, ideally with minimal sample processing. And I was lucky enough to get a collaboration to UNM actually at the Health Sciences Center. So this would be someone who would fit in what you were talking about, Edl, with being the other category. So he doesn't traditionally fit in this. So there's no exclusion based off of whether or not your research fits one of those categories. And the reason we're utilizing him is that the expertise, this is Daryl Dinwiddie, is that his expertise is in identifying sequences for viruses. So what he's bringing to the project is to actually do analysis on viruses and identify areas that are likely to be high mutation, low mutation. How would we detect a variant? Could we detect COVID variants rapidly and be able to adjust that quickly to respond to, say, a growing pandemic? He's also working with us on doing detection for other viruses that are of interest to, like, Department of Defense. So you're talking about the things that we worry about coming in. So Zika, Ebola, that kind of thing. And so the Academic Alliance brings expertise in that I don't have, and really brings a lot to my project. So this is in the first year. So one of the reasons why there are no slides is we're still working on our first year, but it's been a great opportunity. And I'm happy to answer questions, but I've been able to work with a number of the Academic Alliance schools over my time at Sandia, and have found it to be just a wonderful program to be able to work with academic teams as well. So back to you.
Great, thank you, Kim. And just, I was told we're not supposed to use Academic Alliance anymore, but we can use Alliance Partners. So we can refer to them as our Alliance Partner universities. And our final panelist is Drew Suchanek from Sandia National Labs. Drew, you've got the floor.
Hey, thanks, Edl. Hey, everybody, Drew Suchanek. So my background is mostly in computer engineering and applied mathematics. And at Sandia, I am lucky enough to work on a variety of really interesting projects, that most of which I can't talk about. But the basic generality of what I do is I design digital circuits. And so that encompasses creating a lot of ASICs from scratch for specified projects, But one thing about ASICs is it's a long turnaround time. You have a lot of developments, you have several fabrications that you need to go through. So the LDRD I'm actually currently working on and leading that we have an alliance with UNM is on trying to create a fail-safe design implementation on an FPGA, a field programmable gate array that has the same pedigree of fail-safeness that generally an ASIC would. There's a lot of complexity in that because of the prefabricated hardware that is involved in an FPGA, and creating the same mitigation techniques to ensure that if anything does happen or goes wrong, has a fault on the integrated circuit, it doesn't propagate data that you don't want it to propagate. If you can imagine, there's certain situations in high consequence systems, if things were to actually happen and data gets leaked, you could have catastrophic things occur. So I am working with Dr. Paskelik from the engineering and computer department on this. And what that allows us to do is to encompass a wider variety of FPGA fabrics. We're currently using our own FPGA that we're developing here. However, being able to use more open source ones through the university and get a more comprehensive guide and list of how we should develop this RTL that synthesizes on FPGAs is invaluable. So the relationship is very beneficial to both parties. Thank you.
Great. Thank you very much, Drew. All right, so we have our 5 panelists. We have Chris, Aaron, Tito, Kim, and Drew. And I have a few questions that I would like to pose to them. Not all the panelists have to respond to every question, so keep that in mind. My first question is, what are the benefits of working on a UNM Sandia partnership, both in a technical and a non-technical sense? Would anyone like to take that question?
Sure, I can start there.
Thank you, Chris.
Yeah, so the technical benefits, it really depends on the project. For us, it's been really nice because we have this uncertainty quantification method that works great for neutrons, and Sandia has needs for UQ for photons and electrons. So it was a very natural partnership, very natural transition to apply this method to new problems and to try and see its value there. So if you find the right fit of the researchers and the projects, then it's really great technical synergy. From the non-technical aspects, there are some very helpful benefits. One was for me, for our project, I think the flexibility of it has been very valuable. So we actually, we have 2 students who've worked on this project, and we actually had to switch students partway through. The work that we do it's very specialized. You kind of have to get a PhD in nuclear and in computer, in computer engineering too. It's just so specialized, and there's so many different aspects to it and lots of fun data structures to manage. So if you don't have the right student, the project can become untenable rather quickly. And we had a student who was a strong student, but wasn't really that well suited for coding initially. And we actually swapped out the students after the first year and got another one who's taking to it like a fish to water. And the original student actually has moved on to another project. He's a reactor supervisor now for our reactor at UNM, and his project is dealing with that reactor, and he's like the best person in the world I could think for that specific project. So that having that flexibility allows us to find the right fit for each student, doesn't force us to put a square peg into a round hole just because we have strict deliverables or something like that. Flexibility has been really helpful. And then the last point I'll mention before I let other people speak is I think the staffing has been helpful too, probably from the Sandia side. Nuclear engineering in particular they're in a big workforce crunch right now. There's lots of hiring needs. And in the 3 Mile Island, Chernobyl phase of nuclear engineering, staffing really went down, and the amount of nuclear engineers we were training went down. Lots of departments closed actually. And nuclear engineers are in high demand too. They're hired all the time by Silicon Valley because method developers know how to code. And they're actually hired frequently by Wall Street. I think actually one of Aaron's former interns interned at Goldman Sachs after a summer ago or something. But the equations that Wall Street solves, the Black-Scholes equation, is not too dissimilar from the equations that we solve in nuclear engineering. So nuclear engineering's students are in high demand, and having them, get to see the real deal, get to actually be at Sandia for internships, get to know the people they're working with, getting to see the work-life balance, getting addicted to green chili, those kinds of things help make it very likely that students will be retained, and they'll know that this is a really nice place to work and we want to go here after we graduate.
Great. Thank you, Chris. Aaron, did you want to chime in?
Yeah, now is a good time, I think, for me to chime in here. I'd say there are certainly technical benefits. We get to leverage one another's capabilities, facilities, codes, and knowledge, it can be really important. For example, Professor Perfetti is one of a few experts in the area we're getting to work with him right now, which is really great. There's also significant non-technical benefits. What Professor Perfetti was alluding to with the hiring pipeline in nuclear engineering in particular, we're trying to hire staff members right now, and we need more people. A few have gone through our grasp partly because of geography. And I think number one, building good relationships with students and professors that work with students helps us have the opportunity to have good people to hire. And number two, in particular, if we have people that have interest and vestedness in the New Mexico and Albuquerque area, is particularly appealing, because with a really small supply of people to hire, and if we even lose a reasonable fraction of them due to geography, it puts UNM in a particularly advantageous place.
Great, thank you, Aaron. Tito, you're muted, Tito.
Yeah, I make a comment along the lines. Before Christopher, I didn't mention, but my background is a nuclear engineer, master and bachelor, physics and mathematics. But I end up to have a PhD in physics and electronics. So that's why I'm in EC. So it's very tight bond. I understand that why they are in high demand, nuclear engineer. But what I want to mention is technically, Aaron is exactly right. It complements the capability that we have at Sandia and UNM. And the project is this kind of project, these academic alliances are really, really good, because to a certain extent, you are not just, you are in between on basic research and applied research. And so you can develop processes or, so whatever is your project at UNM, the typically Sandia people don't have the time frame to do that, or they have the capability, but the capabilities are booked for larger projects. That was my understanding somehow. So it complements very well the knowledge and the capability. And it opened a lot of opportunity of interaction. It's amazing with those projects, how much interaction and how many people you get to know and what happened at Sandia. So it really opened the view on DOE project and what the Sandia they can do, and what we can do on the other side as a UNM to help some research ongoing at Sandia. So I think those are the two key points. On the hiring point of view, it gives an opportunity to a good student, a student that to be known as Sandia. And so he opened opportunity for providing them thinking about the postdoc eventually at Sandia, or to be hired Sandia. It happened to me. I have one student on an LDRC project, and I have another very good student, which is an American citizen, and is really good process engineer. And we've been talking, trying to hire him after his PhD, and it seems to be a very good candidate for a postdoc. So this is the value. The value is, and amazingly, you can do basic research with Sandia. That's what I like about this project. You can do part of the research is really basic research, and part is applied.
Great, thank you, Tito. And I think a key takeaway is building relationships. I think that is key. And that is one advantage that UNM has over the other alliance partner universities in that we're local and we have a tremendous opportunity to build relationship. I think once you build the relationship, the collaborations will be lifelong. Okay, my next question is, what are some of the challenges associated with these partnerships? Drew, Kim, did you want to take that?
Sure, I can go ahead and start. Due to the nature of the work we do here at Sandia National Labs, a lot of it, the discussions and the partnerships have to be somewhat at a very high level or vague in some respects, just because of the nature of the work. Specifically for my LDRD, we're talking about FPGAs, and there's a lot out there, but I can't share the FPGA we use due to the nature of how it's being fabricated and how it's being designed. So sometimes generalities have to be made because there are security clearances, there are issues with that. But other than that, I tend to see, as long as we both understand the project scope and what we're trying to accomplish, we are both on the same page and we're able to move forward. Thank you.
Kim, did you want to add to that?
Sure. I think the biggest challenge that I've run into is that the applied part that we're work is not often what is being done. And so there's some interesting in trying to develop these collaborations and getting the communication going and identifying the right UNM partner. Well, I think that you guys have done a great job in creating that pipeline. Occasionally, LDRD is an interesting thing because the calls are pretty specific. And so I will have a very specific need for an academic partner. So the biggest challenge has been essentially the equivalent of cold calling people. I saw you at a conference, or I saw your information on UNM's website. I think you'd be a great partner for this. So that's been my biggest challenge, has been identifying people. And so the more that people reach out at UNM, the more I have in my pocket that I can say, I think this would be a great partnership for us down the road.
Wonderful. Thank you, Kim. All right, Chris, did you want to add to that?
Yeah, real quickly. There's one challenge I want to mention was just the duration of the project. 3 years is it's good, but it's hard to get a student completely prepared and completely graduate through 3 years. This is a challenge that most of my grants share. Actually, they're usually all 3 or 4 year grants, and it's hard to get a PhD completely graduated in that time. That being said, we are looking at ways of extending that and supporting the student through that. So I'm happy with the way that that has been shaping up. The other thing I want to mention, kind of on Drew's point, is that the flip side of the sensitivity issue is that if you do have a clearance, I have a Q clearance, one of my students, I think he had an L at Sandia, then it makes a partnership that much more enriching, because you can go behind the fence and talk the real facts there, and it's nice to have that connection that this program makes.
Great, absolutely, thank you.
I do agree that the big issue can be only the, I mean, from a UNM point of view, there is no issue of having the students and working, but every time you want to access the facility, or there are some, even for a publication, whatever, even if the work is a common work, has to be approved, has to be reviewed. So this is probably the only limitation, but you deal with national labs and you deal with DOE. So that's pretty normal.
Great. And I would like to add that those of us on the university side who are used to writing 20, 30-page proposals to agencies, the LDRD proposals at Sandia, it's a 2-pager. So that they are much less painful and much more streamlined. And I like that a lot about Sandia. Okay, another question. What advice do you have for a UNM researcher interested in a collaboration with Sandia? How should they get started?
I give you my experience. So I was teaching seminar classes, and I was inviting Sandia speaker, and that's how I got in contact with my close collaborator at Sandia. I provide him with an invited talk, and then after that we went for lunch, and then we spent all day discussing, and we moved forward. So I reach to them and invite them. If you see Sandia researcher, reach to them, invite them at UNM, have some time. If they are interested, spend some time talking about your idea and what they do in the lab, and it's an easy going after that. Just a simple answer.
Great. Aaron.
Edl, yeah, I'd like to make a comment here. So I can make a comment both on some of the benefits of the partnership, as well as maybe how to start new ones. The reason I got my PhD at UNM was because my former UNM advisor was working with some Sandians that I interned with. I actually came to UNM because of Sandia, got my PhD at UNM, and then now went back to Sandia to work. So that's a benefit here. In terms of reaching out, an example would be Chris Perfetti. He was new researcher, a new professor at UNM, and I just kind of keep an eye on the department at UNM. So I just sent him an email. Hey, welcome to UNM. I know your work is at least somewhat relevant to mine. Let's talk, right? I think that's an example that I would suggest is just trying to pay attention from the university to the labs and vice versa, and reach out to people and talk and see where things go.
Thank you, Aaron.
Oh, may I mention that but this is for technical side, there is a facility, and I don't know how many they know, but it's good to mention. It's called the CINT, Center for Integrated Nanotechnology. That's a good place, and you can have a project which is a user facility project. It's exactly like the LDRD's two-page project. And if you have access to that facility, then you have access to all the labs that they are there, and you can start collaborating or discussing with researchers that they are member of Sandia, and that can enable collaboration, for example. It's a user facility free of charge. So just want to mention, it's a good interface between Sandia and UNM.
Great. And for the benefits of those of you who are at Sandia, you can spread the news. In the School of Engineering, a few years ago, we started this faculty expertise directory. I know Chris Lipid at Arts and Sciences is developing a similar directory, but you can, for example, type in nano technology, and you'll get faculty who self-identify themselves as being. So if you Google UNM Faculty Expertise Directory, that's another resource for Sandians to find a UNM collaborator. And of course, we have the Connect with Sandia form for UNM faculty, which is for all faculty across campus to try. If they don't know anyone at Sandia, that's a great way of trying to make a connection.
And I've had connections both ways. So University of Illinois, one of our current partners, came in through a similar form to what you guys have at UNM, where they reached out and said, we're interested. And I was like, oh, this is a great collaboration for us. But then I've also used a search like what you were showing, and that's how I found my current collaborator. Is I found his interests and just cold called him and said, hi, you don't know me, but I think this could be a great collaboration. So
don't be shy. And as an FYI, we developed the Connect with Sandia form, and then Diane Peebles shared it with the other Alliance partner universities. So that's kudos. Okay. So the last question is, what were some of the goals you had in mind prior to establishing your relationships? So what were some of the goals you had in mind? And I'd like to hear both from the UNM and the Sandia side. So what were the goals you had in mind prior to establishing the relationships?
What do you mean for a goal you had in mind?
I guess, what were you envisioning when you started the class? Like, what was the outcome you were hopeful for?
So I'm happy to go. So the outcome for me, there was two kind of main areas. One is technical expertise I don't have. So I saw a need in my project, something that would take the project to the next level. So I searched for someone who would have that. The other sort of main goal is that as we continue to develop at Sandia, we identify holes in needs for technical staff. And so one of the other main goals is to work with postdocs to identify people who might be a good fit for the department down the road. And so those were kind of my two main goals, is to identify people who I might work with later as a postdoc. I also wanted to create a lasting relationship with the UNM professor I was working with. And I was looking for people whose technical expertise complemented the needs for my projects and future projects.
Perfect.
And I'm hoping that will continue in projects beyond the LDRD. So we're starting to look at applying to outside sponsors for additional funding for what we're doing.
Great answer, Kim. Chris.
Yeah, yep. I think my, just broadly speaking, one of my goals was to solve new problems. In the area I work in, for criticality safety, these methods have created a multi-million-dollar research establishment, people who are funded to work on this all across the country, tons of universities, that kind of thing. And just seeing that potential for photons or electrons for a different kind of problem, I think that just trying to harvest that untapped potential and solve new problems was my initial goal.
Great. Anyone else?
On my side was a way to expand the research that we're already doing and how can it be applied in different fields. So it was an ongoing process. It was not a major goal, but on the other side, when you talk to scientists at Sandia, technical staff at Sandia, it becomes, the goal was to have a long-term collaboration and long-term capabilities that we could have used not just on one specific project, but how we can move forward with other projects. So the reality was a first step in order to create, a plan for the future, enabling what we already doing. So it's a kind of ongoing goal. It's not just one idea and finish there. It was just kind of an ongoing moving forward, and like a tree that it opens up.
Great. All right, we're reaching the end of our hour. I would like to thank the panelists, Kim Butler, Aaron Olson, Chris Perfetti, Tito Busani, and Drew Suchanek. Thank you very much for sharing your experiences and your thoughts about this. Again, the whole goal of this is to encourage more partnerships. And if you have any further questions or need assistance in connecting, I'm the right person to contact. If I can't answer your question, I know who can, and I'll be happy to share that with you. So if you have any questions, please reach out to me. My email and phone number are shown. And with that, thank you for participating in this panel, and I hope you enjoy the rest of the symposium.